So, looking now its application. How do we apply this science we did in a cutting process? Look at this. This is the bar. This is the cutting tool. Cutting tool. This is the workpiece. So, a cutting tool is used to cut the workpiece to the shape you want. A cutting tool is used to cut the workpiece to the shape you want. Is that clear? So if you see here, this cutting tool is shaped in such a way whereby once it runs on this, it is removing. You can see the material is being removed. And it's too thick. The material is being removed. So the whole of this material on top will be scraped off. Now for you to be able to achieve this kind of application, you need to make sure that there is force pushing this. That acting force is this one. It is pushing. Then there is a counter reaction. This is the reaction. Okay? So this is pushing, this is counter reacting. So in terms of moments, we can say moments for us to know what is the reaction on this. I have to do the free body diagram of this one. So we have got it. Your drawing will be like this. There is action one side. Then there is reaction. So the reaction here, we are looking for that reaction there. We are looking at this kind of a scenario. So what happens is, at this point here, this one is pressing. Here it is a bit weak here. It's weak. Here there is a reaction there. Okay? So you are bending this. It's pressing this material there. Meanwhile, to make sure that your workpiece so what happens is, when this is pressing there, this material is going to be trying to rotate in that direction. Are we together? It intends to rotate in that direction. Therefore, it is going to cause pressure there. But to maintain it in the position, there is a reaction there. Can you see? So if I draw a single line, the single line, it will be like it. There is a force applied. There is the reaction there. So I'll say because of the cutting, there is a force applied. There is a reaction there. And there is also another reaction there. To balance, so that the system is balanced. That is why my drawing is like this. So if this bar is thin, the moment there is an impact there when you're cutting, this thing will just twist this part and flip off. But because this bar is quite thick, therefore, the whole of this is well maintained. So you need that thickness there. Okay? So this thickness, let's say it's H1. That is, I'm trying to explain the science we have already dealt with. Now this is the application outcome. So you can easily say turning point. FH must be equal to R2 H1. This, then your R1 is equal to F plus R2. Okay? In case you can't see, R1 is equal to F plus R2. So you would have information in this manner. It is from the drawing of the actual cutting to the science. This is on beams. Okay? So when we are doing science tomorrow, we'll be dealing with this. It will help you to revise in case there is uncertainties here. Any question, class? Any question? We are fine. Okay?